Today is going to be a really uncomfortable day for me because I'm used to being one of the smartest guys in the room, at least when I stay in my lane, which is FPV. But there's a part of FPV that I haven't gotten into, and that's 3D printing, and that's going to change today. My goal in getting a 3D printer is to be able to print the kind of flex filament, like TPU filament, that we use in FPV to make like this GoPro holder here, which incidentally I printed. My goal, that's hard to do. To find a printer that can print TPU well, that has been traditionally difficult and required a lot of tweaking and a lot of learning, and that's why until now I have always left it to somebody else. But I hear that that's all changing and that it's actually possible to get a 3D printer and with no work, minimal work, actually get good results like this. So in this video, I'm going to tell you what I picked for my very first 3D printer. I'm going to tell you why I picked it, and I'm going to tell you what I had to do to get from unboxing it to this. I'm Joshua Bardwell, and you're going to learn something today. Before I tell you all about the printer that I picked, I want to tell you the criteria that I had going into the selection process. Because here's the thing about 3D printers. You can get a $150 3D printer and you can slowly upgrade it until it's just as good in almost every way as like a $900 3D printer. There is this sliding scale, and the amount of money you spend basically just sets you at some point on that scale, and then you just spend more money and upgrade it and make it better. And so you're kind of not really locking yourself in when you select a 3D printer. You're just choosing where on that sliding scale you want to start and how much work and money and time you're going to have to put in to get to the level of quality that you want to get. That $150 3D printer, probably not going to do a great job until you put a ton of work into it. The $1,000 3D printer, probably going to print great right out of the box. So I set a price point of about $200 to $300 as where I wanted to be with my very first 3D printer. And I did that because, number one, if you're into quadcopters, then $200 or $300 is a price that I think you can swallow. That's about what a lot of people will spend on a new quad, okay? There are 3D printers in the $500 price range that are categorically better in every way than the $300 to $200 printers that we're going to be looking at in this video. But I just felt like that was too big of an ask, especially for somebody who was just starting. As I mentioned in the video, the printer that I print is going to be focused primarily on printing flexible filament, like this filament here is called TPU. And the reason for that is that most of the accessories that are printed for quadcopters are printed out of TPU. The more rigid filaments will just break if subjected to the kind of abuses that FPV pilots tend to put their quads through. That being said, as soon as you've got a 3D printer, the world becomes your oyster, and you're going to start printing out of a whole bunch of other filaments. So obviously, we're going to be looking at the printer's ability to print more common filaments like PLA, but the real goal is going to be getting it to print TPU very well. And we'll talk about the challenges that presents a little later in the video. Finally, we're going to be focusing on a type of 3D printer called Fused Deposition Modeling, FDM. And this is actually the kind of 3D printer you probably think of when you think of a 3D printer. The kind where you have a spool of plastic filament that goes into a hot end that melts the filament, and it comes out a little nozzle and it prints the thing. The other kind of printer that we would compare that to is a kind called resin-based, where there is a tank of liquid resin that is cured by UV screen that goes up through the tank. And the reason this would go without saying like a year ago, but it actually turns out that resin-based printers have come down in price and become easy enough to use that a few people are starting to say that beginners might want to think about resin-based printers instead of FDM machines. My opinion is that resin still has some complexities and complications that mean that it probably shouldn't be your very first choice. So we're focusing on FDM machines. Now, you know from the video title that the printer that I got is the Sovol SV01, but I got to sort of acknowledge the elephant in the room, and that is the Creality Ender 3. The Creality Ender 3 is probably the most popular 3D printer in use today, especially at this price point. It is inexpensive. It is open source, so you can actually get an Ender 3-like printer from a whole bunch of different companies, not just Creality, included at every price point and quality point. And it has a huge amount of support because it's open source. There's a huge amount of support from not just Creality who makes it, but from the community. And in fact, when I asked people what should be the very first 3D printer I get, the Ender 3 was by far the most popular answer. So why am I not reviewing that one? Well, I actually have an Ender 3 Pro in the box. I need to assemble it, and I am going to be using it and reviewing it. But Sovol just shipped first. That's the truth. I think that there are some things about the Sovol that make it better than the Ender 3, and there are some things about the Ender 3 that make it better than the Sovol. But since the Sovol came in the mail first, that's the one we're reviewing right now. If you want to stick around for the review of the Ender 3, that's going to come in a few weeks when I put it through its paces. If you watch this video and you decide the Sovol is the right one for you, though, there is a link down in the video description. Let's get on with the review. Now let's go through the specifications of the Sovol. And because you, like me, are probably new to this, I'm not just going to list the specifications and assume you know how to interpret them. I'm going to try and give a little bit of context to how to interpret those specifications. And the first thing we'll talk about is the build volume, which is the maximum size of thing that the printer can create. The build volume on the Sovol is 280 by 240 by 300 millimeters. And if you're like me when I first got started, that probably doesn't mean a lot to you. Frankly, I think the build volume is one of the least important things for, number one, somebody in FPV, and number two, a beginner to think about, because most of the things that we're going to print in FPV are going to be relatively small. And as a beginner, you're probably going to get your feet wet with smaller things. If you know for a fact that you're going to want to be printing much larger things, like if you do a lot of cosplay and you're going to want to print costume pieces, you might want to focus on a printer with a much larger build volume. Frankly, if you know you want a printer with a much larger build volume, you're probably going to be moving up to like the $400 or $500 price range where there's this big step up. Within the $200 or $300 price range, the build volume of the printers, there's a little bit of variability, but not really that much variability. So the build volume is 280 by 240 by 300 millimeters, and that's fine, and it probably isn't enough different from other things in this price range to really matter. One of the most significant differences between the Sovol and the Ender 3 Pro is that the Sovol uses what's called a direct drive extruder. So the extruder is basically a set of motorized gears that turn and push the filament into the hot end, where it melts and then is extruded out the nozzle to make the 3D printed thing that you're making. A direct drive extruder means that the extruder is located right up next to the hot end, so that there is almost no space for the filament between where it melts and where it comes out of the extruder and is pressed. The Ender 3 Pro has what's called a Bowden extruder, and in a Bowden extruder, the extruder gears are mounted on the frame, and then there is a long tube which goes from the extruder to the hot end. The advantage of the Bowden extruder is that there is less weight on the gantry. There's less weight and less mass and momentum as the head, the print head, if you will, is moving back and forth and doing the printing. But the disadvantage is that that nozzle that comes out of the Bowden extruder, there is slop in that nozzle. And especially if you're working with flexible filaments, it means that it can be much harder to get good prints out of a Bowden extruder than out of a direct drive extruder. Now, there are people out there who say, that's a bunch of nonsense. I print flex filament just fine with my Bowden extruder. All you have to do is swap out your PTFE tube for high quality tube and tune your retraction and tune your print speed and yada, yada, yada. It can be done, but there's no doubt that a direct drive extruder is best for flex filament. And there's no doubt that a direct drive extruder also adds precision even when working with rigid filament. Now, one of the disadvantages of a direct drive extruder is that there's more weight on the is it called the print head? I don't know, the piece that goes back and forth and actually does the printing. There's more weight on it. And early 3D printers actually had a single Z-axis, that's the up and down. And then the print head would move out along the X-axis. And as it got further out, if there was too much weight on it, it would actually sag a little bit, and that would create imprecision in your prints. 3D printers with direct drive extruders usually also have dual Z-axis motors, which means that instead of there being a single Z-axis, there are two, and the gantry arm is supported on both sides so that there's no sag as it moves back and forth. And as far as I can tell, as long as you've got the dual Z-axis motors, and the Sovol SV01 does, there's basically no disadvantage to direct drive and lots of advantages. The frame of the SV01 is made of extruded aluminum, and this is basically the gold standard for 3D printer frames today. Extruded aluminum is lightweight, it's strong, and it has these channels molded into it, so it's easy to attach things like the stepper motors or accessories like the spool holder, and it's also easy to kind of move or adjust things as you need to. One of the things that differentiates more expensive 3D printers from cheaper ones are the things that the 3D printer does to help with bed adhesion. Bed adhesion means that you need the print to stick to the bed, so that as the 3D printer is moving around and printing, the print doesn't pop off the bed and then your whole print is ruined. On less expensive printers, you may have to take steps to prep the bed. People use things like they'll put Elmer's glue stick on the bed. They'll use hairspray, or sometimes they'll use painter's tape. There are all these things you got to do. The good news is that the Sovol SV01 comes with a textured glass bed. The textured glass means that, well, I can only speak from my experience. I never had to do any bed prep whatsoever. Just it stuck and it didn't come unstuck. It also has a heated bed, and that means that the bed will heat up, and if you heat it to the right temperature, that also helps with adhesion. I don't really know why. I guess the plastic melts and it kind of sticks to the bed better. It is worth pointing out that the textured glass bed is going to give just a little bit of an unsmooth surface to the very bottom layer of your print. And if you need absolutely glass smooth prints, then you may want to go with a different type of bed surface. But for the stuff I'm doing, the not having to prep the bed every time I print has been so nice. One of the disadvantages of the glass bed is that it's not flexible. Why is that a disadvantage? If you're working with flexible filament like TPU, removing the print from the bed is pretty easy. You just kind of, and it pops off. But if you're working with rigid filament like PLA, especially if you have a print with a large surface area touching the bed, getting it off the bed can be pretty difficult. There's another kind of print bed, which is magnetic spring steel. And basically means that you can flex the spring steel to remove the entire piece from the bed and then just kind of peel the spring steel off of the bottom of the piece. If you're going to do a lot of printing of rigid filaments, it might be worth thinking about whether the bed on the Sovol is actually the one that you want. You can swap the bed, but you might be better off just buying a printer that comes with a magnetic spring steel bed instead. So we've got a heated bed. And we've got the hot end, which is melting the plastic. And we've got all these stepper motors moving around up, down, left, right. And that means we need a beefy power supply. The power supplies for these printers are often rated for 300 or 400 watts or even more. And the better the power supply, the faster the hot end is going to heat up. The sooner you're going to be able to print, the more consistent the temperature will be during the print. And also, the less likely that the power supply is going to spontaneously burn your house down or just die for no freaking reason. And I'm kind of joking, but I'm kind of not. Cheap 3D printers usually come with a cheap power supply. It's not UL or CE rated. It might be a fire hazard. It might not be safe. It might work fine forever. The Sovol SV01 comes with a Meanwell power supply. That is a name brand. It's highly regarded and it basically means it's going to output the power it says it's going to output, and it's not going to burn your house down. And that's a good thing. The power supply on the Sovol is 24 volts. Some cheaper 3D printers use a 12-volt power supply, and that means they have to push more current through the wires in order to heat things up. And that creates more of a fire hazard risk, and it also means that they heat up slower. The next step up from a 24 volt power supply is actually a mains powered heater, which this printer doesn't have. Mains power would mean that the heating elements are running off of 120 or 240 volts. Those will heat up super fast, but that's something that I don't think is typically found on printers in this price point. I don't think. Anyway, it's a 24 volt mean well power supply. Speaking of not burning your house down, the Sovol SV01 also comes with a feature called thermal runaway protection. So one of the risks of a 3D printer is that the heat sensor breaks and the printer thinks that the bed is not hot, and so it keeps pumping electricity into it to heat it up, but actually it's hot. And then it just melts the 3D printer and lights your house on fire and burns your house down. Thermal runaway prevention protects against that, and the Sovol SV01 has it. And really, you shouldn't be looking at a printer that doesn't have it, frankly. The SV01 has a feature called power loss print resume. What that means is that if you're in the middle of an 8-hour print and you have a power outage, when it powers back on, it'll be able to pick up the print where it left off. This is a really nice feature. Some prints can be 40 or 50 hours or even longer, so losing them because you had a power outage is really, really annoying. This is a feature that is more and more common, even on printers in this price range. And again, you probably should be steering away from printers that don't have it just because it's kind of becoming the norm. So like, what else are they missing if they haven't got that? Here are a couple other little upgrades that I noticed on the Sovol that if you buy a cheaper printer, you're going to end up doing these things, but they come already done on the Sovol. The first one is that the place where the heating element wires go into the bed is a common place for the wire to break because the bed is constantly moving and the wire is unsupported, so the wire bends back and forth and eventually breaks off. There is a 3D printed part that you can install which reinforces this. The Sovol comes with that part pre-installed. This is a convenience thing because taking the bed off to install the part is kind of a pain in the butt. If the Sovol hadn't come with it, I'd have printed one and I'd have installed it. And when I went to do that, I was very pleased to notice that Sovol had already done it for me. Another upgrade that people will commonly do to their enders is upgrade the springs beneath the bed. Stiffer springs mean that the bed will hold its level more consistently over time, and you have to do less work leveling the bed. The Sovol comes with get the yellow springs for your ender. Well, it comes with the yellow springs already. Speaking of bed leveling, the SV01 does support the BL Touch auto bed leveling sensor. If you don't know what that is, bed leveling is a maintenance step that needs to be done before printing to make sure that the bed is level relative to the print head. It takes about 5 or 10 minutes to do. It's not difficult to do. And if you have a good printer, you don't have to do it very often. However, some people prefer to level before every print just to ensure the maximum odds of success. And if you're going to do that, having an automatic bed leveling sensor lets the printer take care of it for you as opposed to you having to manually do it. I leveled the bed when I first got my printer and I haven't had to touch it since, and everything has been fine so far. If you're going to go with one of those removable print surfaces, it's more likely that you'll have to level the bed more often because every time you take it off and put it back on again, it may get a little tweaked. Now you know how the SV01 stacks up on paper. Now it's time to get personal and talk about my personal experience using the SV01 from unboxing to assembly to setup, and without spoiling the ending, yes, I did get a usable TPU print out of it. So we'll start with unboxing. I'm not going to unbox it for you on camera, but the packaging was fine. It shipped without damage. It was very well packed. Enough said about that. Assembly of a 3D printer, some of them come as what's called DIY, which basically means the whole thing is a box of parts, and you have to do literally every part of the assembly. You have to install the belts. You have to install the stepper motors. You have to do it all. This is not one of those. The Sovol comes 95% pre-assembled is what they call it. So basically it comes in 2 big parts. This base with all of this stuff pre-installed, and this upper part, which I think is called the gantry, which is this part's all pre-installed. Essentially, if you'd done it before, it'd be about 15 minutes of work to have it ready to go. It took me about a half hour, maybe 40 minutes, because I was going slow. The user manual is very detailed. There's one thing the user manual leaves out. I'll show you that in a second. But basically, you just screw in about 5 or 10 screws, and then you have to plug in all the wires to the stepper motors. This part took a little bit of time because it wasn't obvious to me where every single one of the plugs was. Like this one was a little hard to find. I mean, obviously you can see it now, but I figured it out. Assembly was pretty easy. One of the steps that the manual leaves out is that the manual seems to assume that this filament detector is pre-installed on the gantry, but in fact, at least for me, it was loose in the box. So when you get to the step in the manual where it says, run the filament through the filament detector, and the filament detector's not there, go back, look in the box. It's probably in there. It's easy to install. Another place where I felt that the manual could have been more clear is in the installation of the Z-axis limit switch here. The purpose of the Z-axis limit switch is to limit the up-down, the Z-axis travel of the gantry, and to prevent the print nozzle from crashing into the bed. So setting the height of the Z-axis limit switch is important. And if you set the Z-axis limit switch too high, then your springs will not be under very much tension and the bed level will not be as reliable. So the manual tells you how to install it, but it doesn't really tell you the optimal way to install it. I've got another video that I'm going to put out which goes through all the steps I went through to tweak and tune and set up the Sovol SV01 so that if you've got this printer and you want to follow along, you can do that. But since this is just a review and not like, it's probably going to be a long enough video as it is, make sure you're subscribed and make sure you hit the notification bell if you want to make sure you don't miss when that video comes out. The next thing I had to do was load the filament, and I had the damnedest time getting the filament to go through the filament detector. I wasn't even using this floppy flex filament. I was actually using this roll of rigid PLA, which actually comes with the SV01. You can use it to get your first few prints out of the way. At the suggestion of the very, very helpful people on my Discord server, they recommended cutting the PLA at an angle so it has a pointy tip. I used these cutters, which come with the SV01. In fact, it comes with a full toolkit of all the things you need to assemble it and a few basic things you need to work with it. And once I cut that, it went right through the filament detector and was easy to load. Now remember that my goal is to find out the least amount of work you can do and still get usable results out of your 3D printer. So after I built it and I leveled the bed, and then the very next thing I did was I tried to run a print. Now 3D printers will often print off of an SD card. What you do is you put the SD card into the computer, you perform a process called slicing, and then the slicing process produces a G-code file, and the G-code file is what the printer actually uses to print the object. But the printers will typically come with a G-code file pre-installed on an SD card that also comes with the printer. And the reason for this is that if you screw up the slicing process, if you make all the settings wrong, then the print will fail. And that's your fault because you didn't know how to use the slicer. So the manufacturer provides a pre-sliced G-code file on the SD card that you can print just to prove that the printer's freaking working. And that's what I printed. And this sexy little cube, it's not sexy, but it is a cube, and it's useful for knowing, well, for example, it's supposed to be a 30 millimeter by 30 millimeter cube, and if we get the calipers out, we can see it's pretty freaking close to 30 by 30. It's a little bit off on the x-axis, 30.1 millimeters, still pretty freaking good. On the base, the print printed with something called a raft, which is extra filament that's put at the bottom of the print to help it stick, and as a result, the Z-axis is not going to be 30 millimeters. It's going to be oversized, and that's just because we printed a raft. But the result was pretty darn good. Not perfect. There's a little bit of a layer alignment problem. See this little line right here? Not perfect, but pretty freaking good. So the next thing I did was I took that freaking PLA out, and I stuck some TPU in, and I tried to run a TPU print, and it was a freaking mess. In fact, at first, it didn't even extrude at all. The filament's going in. It has to come out. It has to come out somehow. And it turned out the problem was that the TPU was spiraling up inside the extruder. When we used a rigid filament like PLA, it came out of the extruder gears and it just pushed right down into the nozzle and everything worked fine. But the flexible TPU wasn't working like that. This is actually a known issue with the extruder on the Sovol, and there is a known fix. The fix is to buy a thing called Capricorn tubing, which is PTFE is the name of the plastic. It's a high temperature plastic, and you install a piece of Capricorn tubing inside the extruder. Now, I'm not going to put that in this video. I'm going to make a separate video about all of the things I did. If you buy a Sovol, all the things I had to do to get it working right. Not too many things, don't get the wrong idea, but this was one of the things. If you buy a Sovol, it may actually come with, they've modified the extruder design, and it may be shipping with a modified extruder that works correctly. So don't assume that you're going to have this problem, but if you try and print TPU and nothing comes out your nozzle, and then when you take it out, it's all coiled up, this is what you have to do to fix it. So after doing that, then, well, I'll show you. This little guy here is called Benchy. It's a benchmark print, and although it just looks like a cute toy boat, it's actually specifically designed to highlight problems with your 3D printer. So for example, as the printer prints the bow here, it has to print an overhang where it's extruding filament kind of, instead of directly on top of other filament, it's kind of extruding out into empty space. And you can see there's a spot here where it struggled with this overhang and some of the filament didn't stick. There's other parts of Benchy that highlight other issues, like here we've got what's called a bridge, where the nozzle has to move over empty space as it prints. And we've got something called stringing. Now, TPU is particularly prone to stringing, and there are ways to clean it up. Some people soak their model in hot water. Some people use a hot air gun to melt away the stringing. But this is a pretty extreme example of stringing, and I wasn't really happy with it. Objectively, this is a really crappy 3D print. You can do way, way better. But the first time I saw this guy actually come out, and I was like, well, that wasn't so hard. And honestly, it wasn't. I expected to have to do a lot more work to get even a TPU print of this level based on the horror stories I had heard. But I knew I could do better. And so I turned to two places. Number one, there's a Sovol Facebook group where the Sovol users are super helpful, and Sovol themselves are super active on that Facebook group. And number two, I turned to my Discord server. So I have a Discord server for people who join my Patreon, and there's a 3D printing channel on that Discord server. I'm used to being the know-it-all, but those guys know way more about 3D printing than me, and they were super, super helpful in getting my settings dialed in. There were two things I needed to do to get what I think are, I'm going to show you in a minute, really good results. Number one is I needed to calibrate my extruder, and that's something that I'm going to put how to do that in this other video I'm going to put out with all the things I had to do to get it working. But number one, my extruder was 14% under extruding, which means that not enough plastic was coming out. And so I fixed that. And number two, in my slicer, I set retraction to be, I had 6 millimeters of retraction. And this is a little bit, and again, you don't know what that is, another video. But for those of you who know about that, that's a little surprising. Most people run TPU without retraction, but that's how I got good results. And here are the results that I got. So the first thing I'll show you is this Benchy, which is, I think, pretty freaking clean. This is without any cleanup. There's just the tiniest little bit of stringing, but this is at 30 millimeters per second print speed, which is, for TPU, that's you're not going to get 30 millimeters per second off of a Bowden extruder. I'll tell you that. I fill up the comments with people who are printing with a Bowden at 30 millimeters per second. It's pretty freaking good print speed. So I think this was about a 3-hour print. I did some other torture tests. This is a temperature tower testing the ability of bridging at different temperatures, and yeah, okay, not bad. And this is an overhang torture test, which basically sees how far your printer can print an overhang without it all falling apart. And the standard is that every printer really should be able to do up to about 45 degrees of overhang, and then when you go past 45 degrees, it's printing more and more out into open space, and there's nothing to hold the filament up. And you can see we got to, like you can see here, the lines are completely clean. Right about here, it starts to get a little messy, and that is at about 50 degrees yeah, that's 50 degrees right here. So 55 degrees, around 50, 55 degrees, it's starting to get messy. And then it really starts to fall apart about here at about 60 degrees. But that's pretty freaking impressive, I think, for TPU, which is not known for its ability to do bridging or overhangs. I'll show you one more thing. This is a 3D print of an Acrobat GoPro session holder. I needed it because I was doing a review of the Acrobat, and I didn't have one. So I just downloaded this off of Shapeways or Thingiverse or wherever, and I printed it. And again, I think the results are, like you can see right here, this overhang here had a little bit of trouble, but it was 1,000% functional. And honestly, again, considering the amount of work I had to do to get it working, I'm really, really pleased. And that brings us to the end of the video. And as always, the question, should you buy it? And that question is particularly tough to answer for 3D printers because unless the printer is just awful, it's never going to be just, oh, it's terrible, don't buy it. No 3D printer is like perfect out of the box, presumably until you get to the Prusa price point. And so the fact that there are a few things about the Sovol that we might need to improve, like the fact that we had to put that Capricorn tubing in the extruder. By the way, Sovol has said that they're going to improve the extruder and they're going to ship it ready to go, so you don't have to do that. Maybe they've already done that, so maybe that's even off the tip. My point is, the fact that it wasn't perfect out of the box doesn't mean you shouldn't buy it. That's actually pretty normal. And honestly, for the results I got, I felt like the amount of work I had to do was pretty minimal. So that is a conditional thumbs up for the Sovol SV01. The real question we got to ask is, how much are you spending for the SV01 and how much could you spend for something else and maybe pay less but do a little more work, or I don't know. The SV01 comes in around $300 list, but especially at this time of year, you can find it on sale for as little as around $250. And if you compare to something like the Ender 3 Pro, the Ender 3 Pro I am seeing priced around $220 to $240, which I think starts to make the SV01 look pretty good. If you were to pay $300 for the SV01 and $240 for the Ender 3 Pro, but then you need to upgrade, like if you want to put a direct drive extruder on it, now that price difference starts to shrink. I think the SV01 looks like a pretty good deal. We do have to say that although the support on the SV01 from the Facebook group was excellent, you have to acknowledge that the Ender 3 Pro has a much larger community. In any group you go into, there will be way more Ender 3 users than there will be Sovol users. That's not, like, the SV01 is very similar to the Ender in so many ways. So it doesn't mean that the advice you'll get will be completely inapplicable, but especially when looking for like 3D printed accessories, like I wanted to upgrade the fan shroud. There's a zillion upgraded fan shrouds for the Ender 3 Pro on Thingiverse, and they're just like one for the Sovol. So my review of the Ender 3 Pro is coming, but in the meantime, if you feel like the SV01 is earned your purchase, there's a link down in the video description. It is an affiliate link, and what that means is that if you make any purchase, not just this linked item, but any purchase after you click that link, I get a small commission. That's one of the ways I support myself. Since you might be new here coming in from 3D printing, you might not know this is my full-time job. Yep, I rely on this income to pay my bills, and using those affiliate links is one of the ways I do it. Thank you guys so much for watching. I am really looking forward to making more content about 3D printing. I hope you're looking forward to watching it. That's going to do it for today, though. I got a problem. I finish all my videos by saying happy flying. Should I say happy printing? Happy printing, everybody.